Recording in progress.
Okay, so let's talk about zero matrices and identity matrices, just so you know what's happening with that. So anything plus zero is itself. We know that, right? And that's true for a matrix as well. So if I add 0 to A, I get A. Or 0 to A, still get A. Page 5 in the notes. So if A plus B equals 0, what would A equal then? Negative what? Good. Okay, John, do you need notes still too? Did you forget all your stuff at home? Okay. Okay. If A plus B equals 0, how do you isolate A? You subtract B, right? Yeah, don't overthink it. That's all. All right, man.
No, I was at early lunch. Dude, I gave you everything.
So last month. We can't bring it.
All right. Okay, so A equals negative B. So if matrix A is that junk, and you want to find B and A plus B equals 0, then B is simply going to be the negative counterpart of all those numbers.
Question, but how is that different from the inverse?
It's not. Sorry, it is different. Sorry, this is just a separate thing. That's what I'd say. No, we're just doing a simple operation. That's all we're doing. It's very simple. Oh, that's because I got distracted. That's why. Thanks. Okay. Because I was trying to answer a question right at the same time. So yeah. So does that make sense? Just change the signs. Not that hard. That's a zero matrix. Now, the next one is a little more challenging. Identity matrices. Okay. So here's an identity matrix. Now, this is a part I'm going to ask you guys to show on our test. You don't have to do it for the quiz today because it's new. But I'm going to ask that you show the identity matrix when solving a matrix equation. So that's an I. That's an I. That's an I. AI, yeah, actually, yeah, it does look like artificial intelligence. So anything times 1, we know is itself, right? So, well, we're defining it as that. Yeah, so an identity matrix looks like this. It always has to be a square. It does, yeah, actually. That's a good observation. It's always a square matrix where the number of rows equals the number of columns. And my computer's getting incredibly sluggish, so I'm going to close my browser. Give me a sec. Hold on a sec here. Okay, cool. All right, now I closed it. All right, so we're good. Hopefully my computer stops slowing down. So that's when it happens in the identity matrix, and you're always going to have ones and zeros set up this way. So the ones are always going to be in diagonals like this. So the ones are in diagonals also. Hey, John, I'm going to move you because I keep serious, or you could leave. I want you to stay and learn, but no, you're moving. Why don't you sit right next to Alexander so I could sit closer to me? Thanks. I know I'm taking a big risk by having you sit next to Lincoln. Yeah, you need a chair too. Thanks. But I just need you closer by. All right. All right. Okay, cool. So ones are always in a diagonal like that.
Then be like diagonal the other way, or
no, it's always this way. It goes from top left to bottom right. Now, what's going to happen if I multiply a matrix by its identity matrix? Let's see what happens. Because right now, this is the first time you're seeing it. If I multiply this together, I multiply the first row with the first column. So it's 1 times 1 plus 4 times 0. Then I repeat again with the first row and the second column. 1 times 0 plus 4 times 1. Make sense? Just multiplying like we did on Wednesday. And then I do it one more time. Hold on, Elise, let me just finish and I'll get your question. Do it one more time. Second row, first column. So 3 times 1. Correct. And then do it one more time with the second row and second column. 3 times 0 plus -2 times 1. Okay, when I work it out, what's going to be my first entry? 1. What's going to be my second entry? Well, if you want to say 3, sure, that's fine. How about the top right? Top right. 4 and bottom right? Okay, so go some more. What are you going to say? 1 times 1. It's 1 times 1. 4 times 0. 1 times 0. 4 times 1. 3 times 1. -2 times 0. Okay, what?
Is it okay if you use parentheses?
Totally fine, 100%. Actually, I probably should have done that. I'll do that for the next one. So what's happening here? Did this change at all? No.
Nope.
So that's why it's called the identity matrix. It maintains its identity after the multiplication process. The identity of the matrix does not change. I know you guys may have, you guys remember like in geometry doing the reflexive property in your proofs? What did that mean? You guys remember? Okay, I'm gonna tell Mr. Davidson that. Actually, you probably wouldn't be surprised he said that. I don't either. No, no, I tutor. I should know. It's when the same thing equals itself. It's the same thing equals itself. See, you remember. I know you don't care. Just tell me you don't remember. You can be more honest. Anyway, it's the same kind of thing. You're maintaining its identity. It's kind of like that. So if we do it one more time, if I do IA, so I is this, and A was what again? It was 1. Or I forgot now. My memory sucks.
1, 4, 3.
Thank you. Appreciate it. 1, 4, 3, -2. So it's still the same thing, right? If I reverse it, it's actually still the same thing. If I multiply this row with this column, I have 1 times 1 plus 0 times 3. Or I have 1 times, let me do parentheses because I think you guys like that better, right? Yeah, I'll see how. So 1 times 1. Is that better like that?
When you need parentheses like around.
Oh,
I did
man.
1x1 in front.
It's like this, like that. All right. It's all good. And then I do it again. 1 times 4. And 0 times -2. Running out of space here. And then I do it one more time. 0 times 1 plus 1 times 3. And then 0 times 4 plus 1 times -2. 1, 4, 3, -2. So again, its identity is maintained. Now, why do we care about this? Because this is actually what's happening when you do solve a system of equations in the calculator. This actually process is happening. So I need to kind of explain that to you. Now, what was that? Sorry. Oh, no. I'm just, well, multiplying matrices, yes, in general. But yeah, you could check because but the problems we're going to do in these notes later on the next page will be in the calculator portion. You could check using your calculator if that's what you're asking. Okay. Now when you find the inverse, I'm going to have you guys doing the calc because it's kind of complicated to do by hand. I'm going to tell you right now, if you multiply something by its inverse, it will always equal I. I. Always equal I. So, for example, let's say A, I'm just going to make up a 3 by 3 matrix. Let's say we have, we'll make up a 2 by 2. Let's say I do 2, 5. Actually, let's use the A that we've been using right now. Let's use the A we're using right now. So what was our A value again? Yeah, that's right there. It's right in front of me. 1, 4, 3, -2. Okay, here's what we'll do. Our A was 1, 4, 3. My threes are terrible. -2. Okay, let's raise that to -1 power and see what the calculator says. So let me pull up my calculator.
Equal sign.
It's an equal sign, yeah. Should have actually queued this up earlier on. That's right. All right, cool. Now let's minimize. Okay. So, yeah, that's an equal sign. So to do the inverse, very simple. Hit alpha, zoom. We're going to select 2 by 2 and punch in numbers. You guys know this by now, right? So I'm glad I've actually started this process early, because to actually try to teach the calculator today and this concept might be a little much. Raise to -1. You get some weird stuff. Now, those decimals look daunting. Do you guys know how to convert decimals to fractions? Good. Well, look at you, John. See, moving you did wonders. Look at that. Look at that. If you hit math frac, it'll convert that to a fraction for you. Now, what actually is happening, I could show you guys if you're interested, maybe office hours if you want to stick around, but it's not relevant to the scope of this class. So I'm not going to show you the process of what it's doing, but this is the answer. Okay, now I'm not going to actually do this, but if I were to multiply A, which is this, with this inverse, if I actually were to do that process, I'm going to do it in the calculator to save time. No. If it was honors, yes. Or pre-calculus, yes. And actually, this won't be. We removed it from pre-calculus. This is the only time you ever see this.
That is I.
Unless if you want to be
No.
take linear algebra or econ or data science, or why not? What if you like minor ed? No. I can't wait for the day like you come back after say, I'm a math major now, and
Wait, would you have to?
Oh, no.
yeah, hell yes, hell yes, that's gonna happen.
Mister, you wouldn't have to convert it into like a fraction though, right?
No. Okay, if I were to do this now, guys, quiet please. If I were to do this, oh crap, what did I just do? Hold on. Darn it. Let's try one more time. Hold on. Okay. If I were to do this, alpha zoom, option 2. Sorry. 2 by 2. Let's type in 1, 4, 3.
Can you just leave it as I?
-2. No, I'm gonna show what's gonna happen. If I do second answer and multiply it out, you get back to identity matrix. Whenever you multiply something by its inverse, it always gives you the identity. This is very important for the next page, because this will explain why the calculator can solve these 3 by 3 equations for us. But whenever you multiply something by its matrix, multiply something by its inverse, you get the identity matrix. So this you may want to write down somewhere. Whenever you multiply a square matrix by its inverse, the output will be the identity matrix. So square matrix meaning the rows and columns are the same. Hope that makes sense. Like 3 by 2 is not square, but 3 by 3 is. And there's a reason why I can't work for a non-square matrix. Again, I'm not going to get into that concept. Yeah, 1 by 1 would be a square matrix, sure. No, that's too easy. Actually, you can incorporate geometry principles to this stuff, and that's when it gets really complex. But I'm not going to do that. Yeah, boo. But it just looks like a square. That's what it calls for now. But yeah, but there's ways you can incorporate some geometry principles stuff. Anyway, so let's move on to the last page. So what's happening? Oh, hit second negative. She's asking, how do I pull up the previous answer? If you hit the second negative button, you can always pull up the previous answer, or you just go up and select it. All right, so let me show you how we're going to use this process, solve this problem. And we won't do the 3x3 Bible step, the word problem at least, so you guys can feel confident for the quiz. So we're not gonna finish all these notes today, but I want to show you enough so you can be successful in the quiz. But let me do this one. This is important. And then let me do the word problem. That's important. And then we'll do the quiz. And the test, what I'll do for the test, I'll give you guys the packets. I'll talk more about tests on Monday. But at least I'll give you guys the outline so you guys have it. Try it. Let me talk to the other teachers. I'm open to that idea. Would you guys like it on Friday? Okay, if anyone's leaving, okay, let me before I give you a definite answer, I'll email you guys later this afternoon. I'm meeting with the other teachers during E period. But I will say, if anyone's leaving town early, you could take it early if you're gonna know you're leaving town Friday for whatever wonderful vacation. What's that?
You just want to take the only thing.
We could do that too. Let me check with okay, guys, quiet please. But I do get the feeling that another day could help, or 2 more days could help you guys. I get that feeling in the room. Okay, guys, let me finish so we can do the quiz, all right? It's 9:03, all right? Gonna need about 7 more minutes. All right, you guys ready? Here's what you want to do. We're gonna do 2, -3, 1, 4, x, y, 19, -7, okay? So I know we've done this already, but now I'm gonna get deep. I'm gonna explain why this works. Before you've just been mindlessly pushing numbers, pushing buttons, let's talk about why this works. So first off, this is A. A we call the variable matrix. Because, sorry, the coefficient matrix, my apologies. It's called the coefficient matrix because clearly you're putting the coefficients in there, right? Okay, this is going to be called X. That's what we call the variable matrix because clearly I'm putting the variables in there, right? Lastly, this will be called B. I call this the constant matrix because it has a constant on the other side. Yes, coefficients are constants as well, but these don't have variables next to them, so I just call them the constant matrix, okay? So what actually is happening here is this. I'm gonna write this one more time, and I'm gonna add something to the left of each side. Yes. So let me repeat this. So 2, -3, 1, 4, x, y equals, and you need to leave a gap, by the way. You need to leave a gap like this. Now I'm going to tuck this in.
Oh. That percent too?
Kind of. It's actually, well, think of it as like step 2, sure. Yes, think of it like step 2. So now you won.
Let's be on the test.
Yes.
This.
Yes.
What?
Yes.
Hey, yeah.
Okay. So
Or are you like multiplying it out?
yes, thank you, Elvis. Yes. So here's what's happening, guys. What if you have 2x? What if you have 2x equals 6, right? What do you do to solve that?
Divide by 2.
Okay, isn't division inverse of multiplication?
Yeah.
Okay, yeah. So that's 1/2 and 1/2, right? Now, if you think about it, can I just replace that with 2 to the -1 power? What's 2 to the -1 power?
1/2.
Yeah, right? What happens to these two here? They cancel out, right? That becomes 1 times x equals 1/2 times 6. What's x equal?
3.
I mean, of course we know that, we just look at it, but I know it's a little long-winded. This is the same exact thing. You're taking this matrix, you're raising to -1 power, because guess what's gonna happen to the green and black
Cancel.
matrix? Yes, thank you. They cancel out. Leaving us with just what?
X.
Yes, that's it. That's why this works. That's why we do this method. Because this just becomes 1, 0, 0, 1. John, you impress me, man. Sometimes. Okay. And then you're gonna get some other matrix on the other side here. So that's what's happening. These two become this. These two become something else. I'm gonna use a calculator to do that.
Oh, I see that.
So you could think of this as, so if you want to think of the second line here, step 2, sure. Things is step 2 and things is step 3. I want you to show that on the test. So when I go to my calculator, let's turn it on. Alpha zoom, 2 by 2, 2, -3, 1, 4, raise that to -1 power, multiply it to a 2 by 1. You can put 19, -7, and that's going to get us the answers. Because we've done the inverse to undo the coefficient matrix, you get 5 and -3. And that will be the answer. That will work. Because here's the deal. Anytime this identity is what? Itself.
Itself,
If I multiply this by xy, guess what? I still get xy. What's xy going to equal?
5, -3.
That's it.
Yeah.
And that's why this works. You're basically canceling out this left matrix here. Or essentially moving it to the other side to solve for xy. You've seen this in the calculator often the last few days. Now you're seeing why this works. One more thing I need to say before I talk about the word problem, then we'll start the quiz. One more thing I need to say. What is this really doing? This is multiplying two matrices, right? If you multiply these two, what's going to happen? 2x minus 3y, right? What happens if you multiply 1 and 4 with xy? X plus 4y. What's on the other side? 19 -7. They all line up. That's why we can do this. We can re-express this with the matrix, which makes sense. You know, you write the multiplication. And then if I use the inverse, I can get this isolated to get the values for x and y. That's what's happening.
The solution is 5, -3.
Scary.
Correct. And you let the calculator do its magic. Now, what actually is this doing? How is this happening? This inverse? I'm not going to talk about it with you guys. That's beyond the scope of this course. If you're curious, stick around the office hours, I can show you. Well, just what you're expected to know about matrices in Algebra 2 for the school. We don't go beyond this concept. But in a more advanced class, we would, but more or in a college class, you would see more. So, but if you want to stick around the office hours, I'm more than happy to show you. Just kind of limited to the time right now. All right, last one here. Okay, let's set this up and let's actually solve in the calculator. Okay, so John, since you're such a great public reader, can you read number 16 for us? Read for us, please.
We're going, John.
I'm just gonna hand it out to you guys. I don't have time right now. I'll go over the test outline on Monday.
Company sells 3 types of movie gift baskets. A basic
Okay.
basket with 3
Two.
with 2. I got it. Okay. A basic okay, hold on. A basic basket with 2 movie passes and
Take a deep breath, dude.
popcorn costs $15.50. A premium basket with 2 movie passes, 2 baskets, or 2 packets of God.
The tongue twisters here.
Of pop.
So she sells how much?
Cost $37. A deluxe basket with 4 movie passes, 3 packets of popcorn, and 2 DVDs.
I set you up. I set you up for failure. All right. Okay. Cool.
Who wrote that?
I
Awful.
actually I did.
So hard to read, Mr.
Yeah, I know. Cause
Oh.
yeah. There's some alliteration, packages of popcorns, deluxe basket DVDs. All right. Anyway, here's what you want to do, guys. Quiet down, please. Let's let X be the movie passes. Let's let Y be popcorn. And let Z be DVDs. Or you use A, B, and C. I don't really care. Any letters you want, doesn't matter to me. And I know everyone streams now. This is like this is like from 2008, I think. When
Question?
I think so. Yeah, when I taught Algebra 2. Yeah. Yeah. Yeah, probably when you guys were born. I made this question. Yeah. there's no Netflix or streaming. Actually, there was Netflix. We had the DVDs instead. There was Redbox, yes. Okay, how am I gonna make my equations? I'm gonna make it like this. 2x plus y. I'll put 1 times y.
Well, the twos and the Z.
Is that better?
Yeah.
All right. Plus y plus 0z is going to equal 15.5. Because I use the second equation. You see how I use the second equation? I put 2 next to x, 1 next to y, and 15. It's not a point. It's not a point. It's just an equation. Okay, next up. So this is for basic, guys. That was the basic. How about the premium? 2x plus 2y. Ooh, we get more.
Equals the, or plus the.
Premium.
Equals more money.
Equals 37.
And then find deluxe. Point 5.
History, which pocket did you get?
We'll have kids, so I would probably get deluxe. But then again, we have Disney, we have Netflix, we have Prime, and yeah.
Where let's go there.
Do it. Every time I take my kids to movies, they always buy too much stuff.
Sometimes
Cost so much.
that's like
That's
one
what you do
stop.
like.
That's really.
I'm soft. I can move it along.
Back over.
Like, if you're a little kid, like you have to like get you everywhere.
What?
Like when you're a little kid, you went to the movies. No. Yeah, better.
Bro, definitely smuggles candy in the movie.
Yeah, because my kids will have a lot of cavities. So
Well, I have.
So-
answer.
okay, so we don't waste time. Guys. Quiet, please. Thank you. So if you see what's happening here, I have this system, right? At this point, I'm not gonna solve the system by hand. I'm gonna use my calculator, which you guys
Yes.
know how to do now. I'm not gonna do that in the interest of time. I just wanted to set up for
Can
you
you do
guys.
it in the interesting?
Later. Start the quiz. All right, here we go. Start the quiz.
No. Oh, we didn't do the triple system.
No, I know, it's all.
You don't need raise-
That's what's on the quiz.
Multiply through those.
It's not green.
Make another matrix of 3x1 with prices. All right, and then while you guys work on the quiz, I'll give you guys a review packet. We'll talk more about the test by today.
It's clear.
You guys use your notes, use your homework.
Good job.
Right.
Bro, there's nothing in the notes.
Yeah.
Yeah, that's what I told
Alex, this was you last class.
Do it. And then get on the brink of tears. And then back to breathing, back to breathing, yeah, back to anger. Tears,
Keep going.
anger. Intense anger. Yeah, like that.
Oh,
That
I
is-
tried to make you laugh and you're like,
I'm not gonna catch the wall when I'm having that.
you always told me to throw it.
Okay,
She told you.
you guys, let's work. Let's go. Guys, stop talking.
Okay.
Thanks.
You have a calculator?
Yes, I do. Anyone see a calculator? Okay, no problem. Today's 7th of February. Guys, quiet, please.